The Marine Tech Expo is going virtual this year. Welcome back to Marine Tech Expo 2021 from the UK's ocean city of Plymouth. In this session, we'll be talking more about protecting and monitoring our marine environment and how technology is helping. If you have any questions for our guests, you can share them in the comments box on the YouTube channel, and there'll be another Q&A at the end of this session. Next, we're going to hear from Phil Johnston, who heads business development for Autonaut. Phil's looking at environmental monitoring of the ocean cleanup.
Hello, my name is Phil Johnston. I'm from Autonaut USV. So we manufacture Autonaut's uncrewed surface vehicles. They're wave propelled, so they have a unique ability in that. And also we can send them to sea for many months to collect scientific data and various other tasks. So today's presentation is on the ocean cleanup, the work we did for this fantastic initiative out in the Pacific. It was a superb, this kind of thought leader, Boyan Slat, who came up with this fantastic idea to physically put a barrier in the ocean to collect ocean plastic that was already there, marine plastic that was already in the Pacific Ocean. So to do that, he used this barrier you can see in slide number 1 here to physically collect it. And the idea would be that would be in the Great Pacific Garbage Patch and slowly but surely collect the marine litter that was already there. So our role in it as USV was, on the next slide, as you can see, there were threefold aims, really, 3 aims, and it was part of a wider program. It's a serious endeavour with lots of funding, mainly from the Dutch government and some high-level backers. Our role was to accompany the barrier that was going to be out there. This was very much a test setting a couple of summers ago, and Autonaut would be accompanying Wilson as the barrier was named. And first aim was really to understand behaviour of the system. You know, to figure out how the Wilson system would interact with the environment. Would it move with the currents? Would the marine debris collect within the debris? And how it was going to move around out there. It's quite an understudied area. So that was also a key aim as well, just to acquire something data in the middle of the Pacific. And also ensure that there was minimal environmental impact of the system. Obviously, it's a very green project, but there were real concerns about how it might interact with jellyfish and marine mammals. It was also part of various other technologies. So Autonaut USV was but one of UAV flights, so dye tests, GPS drifters going in there, and also some of SailGP, so Doe & Company SailGP, which is a parent company Autonaut, putting in passive acoustic drift buoys and providing marine life monitoring for the program. But the boat itself, the USV, was at the time the pride of our fleet, although we've superseded that. But it's still a fantastic USV, 5 meters long, and you can see the specifications there. More than happy to go into it here. She was named Eve. That was a reference to a Pixar film, which I've since become aware of through children. Basically, a little robot that was accompanying another robot to clean up the planet. So that was quite rather cute and keeping with the project. We're very, very happy with that. And so it was the cutting edge USV, pretty well stuffed with sensors. And I think it's worth noting for this audience that we did all our testing in Plymouth in the Smart Sound. So you can see this image here of the nicely coloured Eve out in the Sound, where we did all our workup trials before heading to the States and out to the Pacific. And the next slide, you'll see the series of missions that we completed. We worked up from 10 days to 20 days, totally independent mission. We did operate that from the ocean cleanup system support vessel. So the Autonaut was very happy at sea, but the system was running tests, so we deployed from the vessel, and that enabled us to remote control it from the boat bridge at times. Then we would switch to Iridium comms for satellite remote operations from our base in the UK. We built that up, and then ultimately we did a mission of just shy of 50 days, 49.5 days, slightly frustratingly, but that was the USV out there. Entirely renewably powered, so solar energy would power the sensors in the system, and wave propulsion would always keep it moving, always keep it going, an average of 1 to 2 knots. Tracking alongside the system at times, doing close passes, you'll see in the next few images, really getting in amongst the system, so really tight control and track keeping capability. Other times it would be in the far field collecting scientific data, so it could run fully independently. And the tasks it was performing, as I mentioned earlier, just a few slides here on, firstly, asset inspection. The original, there are a few stakeholders in ocean cleanup, what they wanted us to do. I think we managed to keep all of them happy. One of the key ones was asset inspection. There were concerns about the barrier developing tears and fatigue within its structure. So Autonaut was able to get close in within a couple of meters with cameras above and below and physically inspect it. And that imagery was relayed by Wi-Fi to the boat. Also, you can see it's beautiful Pacific clear waters, so we were able to get some lovely imagery of the skirt, if you like, that hangs down from the barrier to collect the marine litter. And that was the success. The success from our point of view was that we were able to really show, you can see here in the images, just show the control, the confidence we had in the USV that's wave propelled after all to stay on track and be where it needs to be and come out of trouble if it needs to. And it does have an auxiliary propulsor on there, so we can just put a little bit of knots on there to get out of trouble if we really have to. The second element that came through was marine life. So this was really secondary. We hadn't totally expected this, but with the cameras on there, we were able to augment the marine life monitoring program that was happening from the main vessel with images of turtles and pilotfish that accompanied both Wilson and the Autonaut, and also marine debris that we're here for, which was a concern for our operators. And we developed, it's always been a risk of entanglement with Autonaut. You've got an endurance vessel out there collecting debris, but actually we developed mechanisms and cutaways and slide-offs to prevent this. So we didn't find it to be a problem. Although we're an area of high marine debris by nature, we didn't impede our progress at all. So that was an incidental little find. But really the bulk of it was the scientific data. The key element of this was collecting data in an area that's little studied out in the Pacific, and wind and wave data was really vital. We were able to get that with fairly simple sensors, but we also need to validate that against more standard techniques. And a lot of that, the drive for the collecting that data has now come through with scientific papers completed by the Ocean Cleanup to find out the interaction of the wind and wave on the surface and how that affects the movement of the plastic. So what's the Stokes drift effect? How is the ocean currents moving below the surface and at the surface, and so on and so on. So really understanding if this system, which has this great ambition, how will it collect the plastic in the future, and how does it interact with its environment itself? So a lot of the data for that program of that line of inquiry was delivered by Autonaut, which we're very, very happy to provide scientists with good information. And also other parameters include temperature, salinity, conductivity, and chlorophyll as well. So again, all feeding into the mix of modelling how the ocean will be expected to interact, and also finding out some of the time frame as well. So time frame data. And we also included ADCP as well. That was integrated in with thanks to our friends at Nortec. We're able to get some ADCP data and also relay that information back to the vessel, which is, we believe, a first from the USV. So we're very happy with that, and that's been developed since, and it will be going out on a mission just this summer off Scotland. So look out for that. So happy clients. The project is set to go ahead again later this year. So we are intending to. We hopefully will be able to come back and update you further on further mission time for USV and the Pacific alongside the Ocean Cleanup. Before that, though, do need to say, obviously, thank you for appearing this, slightly strange expo. It would have been great to do it in person, but hopefully it works and you get to see some of the fantastic kit in the smart sound in semi-real life, virtual real life. And just to note, obviously we're excited to deliver a USV to PML recently, as I'm sure many of you are aware. The PML Pioneer will be out and about in the smart sound very, very soon. So this is now our cutting edge vessel, and it really is crammed with scientific sensors. James Fishwick has been a testing client at times, but it's done us good. Thank you, James. So thank you all for listening to the presentation, and look out for the Pioneer soon, and feel free with any questions. Thank you.
Our thanks to Phil Johnston from Autonaut. Dr. Anna Yunnie is our next contributor. Anna is a professional applied scientist at Plymouth Marine Laboratory Applications Limited, and amongst other things, she's been involved in establishing UK and international regulations and testing for in-water hull cleaning of commercial vessels.
Hello, and welcome to Biofouling and Solutions. So just to give an outline of what I'm going to talk about, I've introduced myself and the company I work for so that you know who I am and where I come from. I'll give a very brief history and introduction to Plymouth's maritime history and also the topic of biofouling. And then I'm going to talk about some solutions for dealing with this problem, both traditional and developing technologies, but in a very broad, high-level way. So if there's anything you'd like to know about in a bit more detail, then please do give me a shout. So to introduce myself, my name's Anna Yunnie. My job title is Senior Applied Scientist, and I'm a marine biologist and ecologist by training. And in the company I work for, I lead on marine biosecurity and biofouling surveys, non-native marine species, hull cleaning, and I also provide expert evidence in legal disputes over whose fault it is that a ship's bottom is covered in barnacles. I've also taught undergraduate courses, PhD students at the University of Plymouth, and co-authored lots of papers on non-native fouling, and a part of the GISAMP group that advises the United Nations on biofouling. So here we can see the company that I work for is PML Applications, which is part of Plymouth Marine Laboratory. So that's the trading arm. So we're a non-profit charity, and that means that all the money that we make from the contracts that we do in applications goes straight back directly to help fund the science and the scientists in PML. So most of our customers come to us either to help in early stage R&D of some new technology, or to perform independent efficacy testing of a new technology, or they've some form of infrastructure that needs a novel approach to look after it underwater, and that's where we come in. Plymouth has a very, very old relationship with maritime industries and historic events, militaries, and also some very famous characters from history, as you can see on the slide. So we've got Francis Drake, Walter Raleigh, both led ships from Plymouth, very famous ships and voyages. Napoleon Bonaparte, he was imprisoned on a ship in Plymouth Sound after his defeat at Waterloo. 1620, the Mayflower set sail for the USA. 1768, James Cook took HMS Endeavour to the South Pacific. And in 1831, Charles Darwin boarded HMS Beagle to go to South America, 2 months in Plymouth, which he later recalled as the most miserable which I've ever spent. But moving on to modern day, hopefully happier times. Plymouth is home to Her Majesty's Naval Base Devonport, which was designated in 1691, but now it's the second largest naval fleet in Western Europe. We've got Mill Bay, and it was a commercial dock, a coaling station and a shipbuilding yards, which sadly it isn't anymore, but it is now an international ferry port to France and Spain. We've got Catwater, and that acts as southwest dock for China clay, salt, fertilizer, petroleum tankers, loads of other things, and that's got connections to Mexico, Spain, and Central America, and that's able to accommodate vessels up to 150 meters in length. And then we've got Turnchapel Wharf. So I'm sure there's a lot of people speaking from Turnchapel Wharf today. It's a hub for maritime development and technology. And that's not to mention all the marine science excellence that's produced between Plymouth Marine Laboratory, the Marine Biological Association, and the University of Plymouth. So we have a long history of pushing maritime boundaries, both past and present, and undoubtedly in the future. So trouble is, all those ships, they bring in more than their cargo. So they bring stuff in and they take stuff out with them to the next port of call. And anyone who's ever had a boat will know exactly what that is. It's the biofouling that accumulates on the underside of a ship. So to define biofouling, it's the undesirable colonization of man-made structures immersed in seawater. And that happens from compounds, microorganisms, plants, and animals. So if you think barnacles, you won't really go far wrong. But You also get sponges, algae, mussels and oysters that you're probably familiar with, but also things like ascidians, bryozoans and hydroids that you might not be so familiar with. And all of these start life off as tiny animals, tiny larvae in the water looking for a place to settle before they metamorphose, much like tadpoles into frogs and toads. And they metamorphose into completely different adult and sessile or non-moving phases of life. And they'll remain where they settled and filter feed and reproduce copiously for the rest of their lives. So as we can see from the next slide, it's not just the holes that these organisms settle on. It's all these complex underwater structures known as niche spaces, like the propeller, the sea chest, the bow thrusters. And these areas typically have small crevices, corners, right angles that are particularly loved by biofouling organisms in their juvenile stages when they're swimming around and looking for a place to settle and metamorphose into this sedentary adult form. So, you know, species, again, like barnacles being a very obvious example, that love to find a right angle. But where do they come from? So if you're familiar with Strava, you'll be very, this map will be very intuitive to you. These green lines are essentially heat maps of the international commercial shipping fleet's passage routes. So today, the international fleet leaves a remarkably distinct signature, and the fleet is only growing in size, in speed, and even actual routes, things like the Northwest Passage opening up in recent years. So what that means in terms of biofouling is that these bright green lights are super highways for fouling organisms to hitchhike their way around the world on these vessels. And of course, these vessels are getting bigger. They're getting, there's more, because they're bigger, they're getting more real estate for their settlement. So they're getting to the destination faster, going to more locations, and it's getting easier and easier for them to hitchhike and survive these journeys. And while this hitchhiking's gone on for as long as we've been at sea, the opportunities for this luxury travel, they're increasing. You know, together with seawater temperature rises, some species are able to expand their range into previously inhospitable locations. But why do we care? Is this causing any problems? Problems for the shipping industry or the environment, maybe? So simple answer, sadly, is yes. So biofilm is the very, very early stages of fouling before you get recognizable animals like your barnacles. And that's a mix of things like diatoms, bacteria, other tiny organisms that create this slime layer very, very quickly on underwater surfaces. And even that, well before you get the big stuff, will cause a significant drag on a vessel trying to power through the water. And it's hard enough. You imagine trying to push this enormous vessel through the water. But if you add an additional layer of fouling organisms, even if it's just slime, to this exterior of this beautifully smooth hull, it will cause resistance. And as you can imagine, the fuel to push this enormous lump of steel through the water costs an enormous amount of money. And it can actually account for 50 to 70% of the voyage expenditure. So it's the biggest single expenditure for any ship and voyage. So any percent increase on that is going to be highly significant. And just to sort of put it into some kind of context, as sort of a single 28-day round trip voyage for a typical trans-Pacific oyster, the fuel bill, and it does depend on the price of oil, but it'd be somewhere in the region of $1 to $3 million. So again, you know, if you think of a 20% increase on that just from biofilm, that's a very significant difference. So what about the environmental cost? All these hitchhiking organisms colonizing new location is a really big threat to native biodiversity. It adds enormous costs and risks to aquaculture industries, and it can even be a threat to human health with things like cholera and E. coli. The last figure we've got for this cost is £40 million a year. But this is undoubtedly a massive underestimation, and the figure's way out of date. And as far as I know, we don't have anything better than that. But in addition to this, when you've got all that drag and you still have to get to that destination port at the specified time. So to do that, you have to use more fuel to get there. And doing that means that you're emitting more carbon dioxide, nitrogen and sulfur oxides into the atmosphere. And obviously that's contributing more to global warming. So there's very much a cost to the environment with all these biofouling going around the world. So enough of that negativity. Think about solutions. That's what we're all about. So first of all, we'll look at prevention. So anti-foul coatings. I'm not going to go into any detail here on anti-foul coatings, but we just say that, you know, there's several different mechanisms by how these coatings work. But about 80–85% of them, possibly more, of the international fleet, they'll use biocidal coatings. And nowadays, these are largely copper-based. But the important thing to note is that there's no silver bullet when it comes to coatings or any other anti-foul solution. operational profiles differ drastically between, say, a military vessel and a commercial tanker. And there's huge variation within those two classes of vessel as well. So, one vessel with a lot of time or idle time in a tropical location is going to need a very different coating to one that's constantly steaming with only short stays in temperate waters, for example. And that's horribly simplistic, but it makes a point that that's a large part of the work that we do, is to test coatings for specific uses and profiles and locations, like the test rig that you can see on the bottom right of the picture. And that's testing various coatings in a very strong tidal flow in Scotland for turbine application. So, it's important to say that the coatings companies are constantly developing new coatings with less biocides and no biocides, and several of those are on the competitive market. So it's still very much a continuously developing industry, and they are working very hard to lower the biocidal load. So as well as antifoul coatings, there are other technologies on the market and in development besides coatings. So these are constantly being developed and improved to lessen the reliance on biocides. And two of those are UV LEDs and ultrasonics. So UV LEDs are being developed by Philips and AkzoNobel. They're not yet on the market, but they are, they're pretty well on the way. So that's definitely one to keep an eye out for. And ultrasonics, and they've received a lot of attention, mostly on smaller vessel in the niche area markets, with mixed results, but both are still very, very interesting to watch and keep an eye on. And another solution that's in the development stage is biofouling sensors, and this will signal when fouling's reached a level that requires attention. So you won't need a diver to do an inspection. It's not a subjective thing. It gives an absolute figure to optimize maintenance costs and times. And this will allow you to clean proactively without trashing your coating. So you're not cleaning it, again and again and again and depleting the coating. But it's not guessing during these static times either. So a vessel would have several of these sensors to identify hotspots around the vessel. And it would give you some detail about your vessel in particular locations, in particular conditions. So that would inform you maybe if you needed to use a more suitable coating for that particular type of passage. So it's very much in development, like I said, between the organisations that you can see on the slide. But it is being funded by MBIC and the Impact Lab. And hopefully in the near future, we might see something coming forward from there. So it's all very well having a multitude of coatings and numerous alternative niche options, but given the ever-increasing amount and variety of marine infrastructure, say from wind and tidal turbines to autonomous vessels and military assets, the variety of operational profiles, it's very much not a case of one size fits all, and there certainly is no silver bullet. It's something we say all the time, really. So, this is where we come in to perform independent testing for either for the coating and technology development or for the users, with specific needs, such as the military. So we can design lab experiments to screen out options that, there's no starters, and we do that using culturing techniques of various fouling organisms, and then we expose them to these potential technologies. And we can also look at corrosion characteristics here, which is obviously very important too. And then we can take the best performing options in the lab out to the field, which for us is a marina 5 minutes away from where we work. And we've got an array of various bespoke test equipment, which is designed and built locally for us. And that's used to test throughout the year. And we can do 2-week to multi-year performance tests in, basically in real world conditions. So we've also got the option to perform this in Mexico if needed, but sadly, I've never made it there yet. And then finally, we can take the best of those coatings and subject them to offshore fully dynamic testing. So that could be a patch test on our research vessel that you can see at the top, and that's Plymouth Quest. We can attach it to our offshore buoy in terms of panels attached to the surface or under the surface, or we can have a bespoke rig that's specifically designed for a certain project. And all of that will come with full environmental data, so we give as much information as possible on the performance capability of the technology. So those are all prevention solutions, but even with the best coatings and the best technology, it is really rare for a vessel to be able to stick exactly to the recommended operational profile required for optimal performance. And ships typically will need, or they benefit from, a clean in between the expensive dry dockings to maintain this optimum fuel efficiency. So often now as well to comply with strict environmental regulations for entry into countries' ports. And we're seeing this more and more as time goes by. And that is where in-water hull cleaning comes in. So they are basically underwater lawnmowers, and these are used to remove biofouling in between dry docking and recoating. And these are single units. Some are ROV driven. I think you can see that on the top left and the bottom right pictures. Some are diver steered, like the bottom left picture, but all are using some mechanism, usually brushes, or a group of brushes or high pressure water jets, to systematically remove biofouling, whether that's biofilm or macrofouling. And I call this slide the past, but traditionally, if you can call it that, hull cleaning has been done by things called brush carts. And all that biological and biocidal debris simply been thrown out into the surrounding waters. And calling this the past is somewhat wishful thinking, as it is really still in the present, with noticeable increase in activity in small South Pacific islands where marine and biosecurity regulations are lacking. So from a practical and a legal point of view, biocide contamination of sediments within a port where they're carried out, I mean, ultimately that can lead to a loss of a dredging license for the port. And if that happens, the shipping channels get clogged up, and potentially that leads to a huge loss of business. And obviously it's the more lucrative, bigger vessels with the deeper drafts that are going to be the first ones to go. But with an estimated 1 billion tons of biocides released into the sea every year, it's perhaps not surprising that this operation has been banned in several locations. So in the last decade, the next generation of hull cleaning technology has been emerging. And the demand is increasing as more countries ban open circuit cleaning, and it's likely that the IMO will eventually turn this into a convention the same way as the ballast water treatment systems are now required internationally. So these systems have a variety of weapons to capture debris, from sort of containment skirts around the outsides to very large suction pipes that go up to the surface, and then multi-stage filtration units, and some have UV treatment systems before the water is returned to the sea. And a few have even worked out ways to recycle the waste, and so they can do things like biofuel or fertilizer. So, this is really forward-thinking stuff. But obviously, there are challenges that remain. There's the ever-present issue of niche areas that are difficult to access, and then difficulties reaching areas with high curvature. So divers, there's still a use for divers. There's still need for things like propellers in particular. And this is the holy grail for everybody, the perfect solution for niche areas. If you can come up with that, that's a golden goose for any aspiring developer. Another major development, this one's quite exciting, I think, is the development of what's called hull grooming. So instead of waiting for the hull to be fouled and doing reactive cleaning, you proactively clean the hull, much in the way that you hopefully clean your teeth to avoid the growth of unwanted bacteria and decay. So because at the moment, there's no real evidence of biosecurity risk from the moment of biofilms, the fact that they're gentler as well, and the fact that there is no real issue identified, there's currently no requirement for the complex capture systems that we see on the full-blown cleaning systems that we see. So that does make things a lot easier. Of course, if you're going to do this proactive cleaning, it's a case of little and often. So every time the vessel's idle, you might want to deploy the system, although in the case of one manufacturer, it's actually all monitored and controlled remotely from Norway. This is currently under multi-vessel trial, but it's really looking like a contender for the future of shipping, or future in the shipping community. So very much one to watch. And again, it's a question of choosing the right cleaning system for your needs. It's not a one size fits all. So you might have a tanker or a military vessel. There's lots of talk about adapting systems to clean underwater sections of wind turbines and aquaculture pens. And again, it's important that these devices are independently tested, and the organisations listed here, BIMCO in particular, are all involved in creating efficacy test protocol and international guidelines and regulations. And eventually it's likely that that's going to lead to type approval testing in the near future. And we've been collaborating with all those organisations on the slide, and we've been in discussion with UK agencies helping manufacturers navigate UK regulations and present their evidence and interpret evidence that sometimes isn't that easy or clearly or robustly done. Manufacturers don't necessarily understand some of the reports that they can get, and again, that's where we come in. But the standards are, they're being trialled at the moment, and that's very much something that we'll be working towards. But the dream, the OceanGate dream, this is my big one that I'm after. So the dream is to have a UK-based specialist hull cleaning combined R&D and test centre in the southwest. And ultimately, the idea would be that hull cleaning and grooming devices would come to us as an R&D and test centre with standardised infrastructure, so shapes that will replicate the shape of ships and turbines and stuff. We have a known fouling pressure, and then we can produce independent, impartial tests of various types for various standards or applications. Or users such as military or tidal turbine companies, aquaculture companies, whatever, they could come to us to work out which is the best technology for their requirement. And we could do all of this by setting up a test site in the basin's ocean gates. Everything's there basically for us. So it's watch this space, and one day Plymouth might have yet another feather in its already well-plumed maritime hat. So that's all for me. I've got my contact details there. If anybody does have any questions, please feel free to give me a shout. Thank you very much.
Thank you to Anna Yunnie. Now, one of the most competitive races on water, SailGP, is being staged here in Plymouth. The event is in the process of making the transition to clean energy by 2025. And to explain more, here's Thibault Laudren from France SailGP team.
So hello everyone, my name is Thibault Laudren. I'm the operations manager for the France SailGP team, the French team who is going to participate in the SailGP Plymouth event this weekend. And I'm also the on-water transition project lead for a specific project run by SailGP around minimizing the impact that we have on water for the events we organize. So what I wanted to discuss with you today in particular is how us as an international event and championship, we put ambitions in trying to minimize the impact we have on the water in every cities we visit, such as Plymouth this weekend, and what are the challenges we're facing today to make sure that we are a sustainable event, and we inspire our sport to make a change to clean energy. So I think maybe a little bit of a background around SailGP. So SailGP is an international league which has events in all 4 corners of the world. We have 8 teams with the French, the Kiwis, the Australian, the British, Spanish, Danish, and Americans, and the French. And we are competing in a 2-day event. It's so 8 boats, which are 850s. These 850s are sailing catamarans, foiling catamarans. So as you can see here on the deck, you will these are boats which have a wing, like a wing of an airplane, and then are sailing on foils to reduce the drag. So this proved to be really a fast boat. They can achieve speed of up to 50 knots. And the concept behind SailGP is having 8 nations sailing against each other on similar boats. So the boats are all one design, and exactly the same, and only the sailors will make a difference. But as you can see here on the picture, you only see the F-50, but the behind the scene is a little bit different. We have about 30 to 40 power boats that we have with us at every event to help us organize the racing. It can be around race management, marshalling, broadcast, safety, hospitality, and we also have a boat per team to have the show team on board in case of any specific technical issues that need to be fixed in between the races. So we will have an event this weekend in Plymouth, and so far the way we've tried to set objectives around how impact and how do we minimize the impact of our events in the places we visit. We've tried to look at different opportunities we have to do so. And then this goes from reducing the number of boats on the water, the number of days on the water, how far are tech bays placed from the racing area, how do we minimize the risk with mammals, or how do we minimize the risk or the impact we have on the seabed whenever we have some mooring set up or the racing marks. And the most important piece is how do we operate, and what sort of technology do we have on our support fleet to minimize our carbon footprint in particular.
So as you can see on this slide as well, this is a kind of a cloud, we call it, of opportunities we think are very much related to what we can do at SailGP to inspire other events to do things differently. These other events could be what we have in the Olympics, maybe the America's Cup, maybe similar events, or maybe it can even be simple events you have at the local sailing yacht clubs. The very main project and the most ambition one is how do we transition the fleet of support boats from fossil fuel engines to renewable energies. We have about 20 boats that we own and that are traveling with us in containers from event to events. And we have about 20 other boats that we charter at different locations. As is per the technology today, it's all about fossil fuel engines, as you can see on the picture here, and then we're considering different options on having maybe electric engines or hydrogen engines or maybe diesel engines running on HVO, which could prove to be a really good solution, either short-term, mid-term or long-term. The interesting aspect about these particular opportunities of reducing our impact is that there is no existing technology yet that could fit our needs. It means like what are the requirements for our boats in particular in terms of speed, of horsepower we need, the range they also need to cover during a full event. And for this, we've set up a roadmap which goes from season 2 here in 2021 to season 5 with 3 phases. And we are this season at phase 1, which is the first step of what could be a really big project for us. The first
thing is how do we reduce the number of boats and days on water? So we've managed to reduce the number of boats on water by assigning dual roles to certain boats that could either be a marshal at the beginning of a day and then transfer to be maybe mark sets during racing and then back to marshal. So you also have boats who could be helping with the training and the viewing of the boats when they're being launched, and then join the racing and have a second role as well. And then there is another aspect which is really important, is whenever we have discussion with companies developing technologies, either on electric,
hydrogen, or potentially diesel, they always ask us what are the specific requirements of your fleet. And the fact is we have different requirements depending if you have a broadcast boat or maybe a race marshal, a race management, or even a short team boat. And then in order to achieve this and come up with proper data, information and insights on what we need exactly on our fleet, we've developed a system of monitoring where we have all our boats have sensors on board, and we're using data provided by one of our partner, BNG, and then all our boats have BNG equipment on board, and these boats can then send data through a telemetry system onto a database where we can access information such as speed on ground, the engine fuel rate, the engine RPM, the amount of fuel we've been using. And by having this data covered over a whole lot of different events from the beginning of the season to the end, then we are able to do some average and then understand what are the requirements of a boat depending on its role on the water. And with this data, then we can have discussion with our technology suppliers on which technology we should then have on these boats that would make a lot of a perfect sense for this role. Then another project which is really interesting is how to minimize the number of days boats on the water and the number of days they are on the water. It's also in trying to have operations that are done remotely. So we are now doing remote umpiring, meaning we don't have any umpires on the water anymore. And here you can see different tools that we're using, which is one main tool actually, which is named UmpAmp. And this software gives us on a map the exact position of the different boats on the water, on the different F50, and you can see which one is on starboard, which one is on port, and from actually the other side of the world, you could see in real time if a boat needs to be assigned a penalty. Here in the left bottom corner, you can see a very precise situation where we had the French team and the Spanish team in Bermuda, the first event of the season, end of April, where the Spanish team arrived from the top of the line to windward, and then didn't have priority, but still tried to push the French and to cross the starting line. So this was a situation where the Spanish had a penalty. And if you look to the right of the screen, you can see this exact same situation on the software, where you see the Spanish boat at the very bottom and then French just on top of them. And then you see the next situation is you see the Spanish boat having a penalty where you have a red square around that boat. So the umpire would be able to assign a penalty from wherever they are on the world, and then that penalty will be directly transferred onto the F50 of the team that will see a flashing light and then knows that they have a penalty. They will also be made aware of that penalty through communication on board, and they will know that they have to slow down and let the other take over. One of the other projects we're doing as well is how do we minimize the impact we have on marine life. And here is an example of what we did at the second event of this season 2 in Toronto, where there was a large population of bottlenose dolphins and other mammals visiting the bay, such as sea turtles as well. So we've set up a different alert level area from 1 to 4, and we had marine mammal observers on the water who were monitoring the presence of animal at all times during the practice, racing, and the racing days. And in case of an animal coming into these different areas, and we had communication going from the marine mammal observers to the race management. And if the animal were eventually making it to the alert level 4, you can see on that map here, we would be delaying the racing by 10 minutes. Even if we were on broadcast, we would immediately stop the racing at the last mark, and then we would wait for the animal to leave the alert level area, alert level 4 area, and then for us to resume racing. So these are different projects we're running here at SailGP with the purpose and impacting, but also involving all the different departments. The main objective is trying to find solutions to challenges we're facing at every event on a daily basis, and come up with technologies, innovation, or sometimes just a management of our resources in a way that can benefit the environment and our planet and our playground, because we are spending a lot of time on the water, and we want to make sure that we leave it as it is, or even better when we arrived. So these are a lot of different projects we're running right now, and then you will be able to discover more during the broadcast of the SailGP this weekend on Saturday and Sunday in Plymouth. So thank you very much for your attention, and I look forward to answering your question.
And I'm delighted to say that Thibault Lavrun from Team GP and Phil Johnston from Autonaut are with us to answer your questions. If you have any questions, you can post those in the comments section of the YouTube channel. Phil, I wanted to come to you first of all and get a little bit more of a background to Autonaut. How did it come about, and where's it based?
Oh, sure. Well, it's now based in Sussex with a presence in Devon through the parent company Sage. But the story really goes back to Tavistock. So it was developed in a shed of Mike Poole, the original inventor, and developed from there. And Plymouth has always been central to that. It's been all the early prototype boats were out the Sound, and then as Smart Sound's come around, it's been a joy to be part of that. And then in terms of the ocean cleanup, the Eve boat was trialled and tested right here on the Smart Sound before heading off to the Pacific.
You explained a little bit in your presentation about the objectives of Eve, but just go into that in a bit more detail for us. What were you setting out to achieve with it?
Sure. Well, for Eve, I mean, it was a fantastic, unique project to be involved with. The kind of the dream of the idea of having a barrier to collect marine litter out there in the sea already was was obviously very, an idea very close to our hearts. So we did what we could to support the ocean cleanup guys. And a few ideas percolated around, but we settled on asset inspection. So physically getting close to the barrier and using cameras above and below to inspect the barrier. They were concerned that it would break at various points. And then other ideas began to creep in, a science piece in terms of collecting meta-ocean data and data on the ocean currents, which we did with the Nautic ATCP, both close into the barrier and further offshore, and also the marine life element as well, so capturing images of turtles and fish, as well as the marine life program that was going on by SailGP.
And before the deployment, tell us a bit more about how Smart Sound in Plymouth helped with the development.
It's huge. I mean, as I say, it's been in our DNA. We've been testing here, earliest prototype boats. A lot of the time, heading out from, sort of people around here will be very familiar with the story of Autonaut and how it's had its ups and downs. But now it's just a pleasure to be part of this very streamlined showcase of marine autonomy. And the icing on the cake for us is to have the PML Pioneer as part of the furniture out there in Smart Sound.
Lots more questions for you. I want to bring Thibaut in at this point, though. What's already changed, Thibaut, in terms of changing SailGP in terms of its clean energy, that transition? What sort of progress have you made so far?
Hi, Justin. Thank you very much for having me. And sorry if it's a bit noisy behind me because I'm at the Plymouth tech site right now. So we have the boats being built next to me. We've seen a lot of progress. I would say the most interesting one is probably a human progress in the sense that we've seen a change of mindset within the organization. People who've been in the industry for maybe 15 or 20 years, who've been working on a lot of different events, and who are the one making it happen behind the scene. We are seeing a mindset for these people on how they want to operate on the water, and this then directly translates into concrete actions. We see people trying to optimize the way they use their ribs on the water, on how they chase the F-50 during training, how they organize the training with the coaching, how each team is actually trying to minimize their logistics in terms of accommodation, transport, and I mean, a lot of different areas where we can have an impact on minimizing our carbon footprint.
What was the motivation for looking at this? Because clearly you're a sailing event, so the actual competition itself, one would assume you're not using a huge amount of energy on the water, but we've seen from your presentation about the support mechanisms around you and the energy being used. So what was the catalyst for trying to change things?
I think it's, we're all passionate about sailing, and so we are passionate about the sea. And the sea is our playground, so we want to make sure we can take care of it. We're very conscious that wherever we go, we can see impact of the climate change, and we want to make sure we try to do our best to minimize this. We also think we have a responsibility to go beyond sport and try to have a society impact, both environmentally and socially, in making our sport more inclusive, in trying to find innovation technology who could help us minimize our impact, and that this could then go and move on to other events, maybe to sailing clubs, and at the end of the day to the daily boating community. So and actually I would say also that this change of direction, or slightly change of direction, because this was already initiated back in 2018, happened with the pandemic. We had to stop our league for the whole season 2. So we stopped in February 2020 in Sydney. And the first event we had then was in Bermuda in April 2021. So we had a full year to actually understand how we could improve, what else we could bring to our sport. And since sailing is so much connected to the environment, it felt very natural to be working on a sustainability plan to minimize our impact with strong targets, such as minimizing our carbon footprint by 55% by 2025 and being powered by renewable energies fully by 2025.
And how far does this aim extend to the construction of the boats themselves?
So this is a really interesting question. Obviously, the boats are made of carbon fiber. We want them to be light, to be stiff, to be very reliable as well. So we're having a partnership with a company named Gen2 Carbon, which is a UK-based company who is trying to source solution on how we could reuse carbon waste and transform it into new pieces.
We're also trying to monitor the way we build the boat in minimizing the number of new equipment we bring on board. And then there is actually a really interesting story behind it. The F50 we're using right now were called AC50 for the America's Cup in 2017 in Bermuda. So the 8 boats that we have right now called F50 are actually repurposed AC50. So we bought them secondhand and then we transformed them to so they could be all one design. And we obviously made a bit of a few modifications to improve the performance as well.
So that the sailing a version of upcycling, effectively.
Exactly, that's exactly it. And then, I mean, we have a really strong community of partners who are with us on this journey on trying to find alternative solutions. You know, it's not only about the F50, it's about everything which is going around it. It's only 8 boats on the water, but it's about 150 to 200 people at every event. It's about 85 containers that we transport around the world. It's a fleet of between 30 and 40 support boats, ribs, power boats that we have at every event. So there is what we see on the TV, and then there is what's happening behind the scene, and we know is where we can drive impact most.
Lots more questions to come for you, Thibaut. I'll just come back to Phil at this point. The aim is the same in effect. You're all working towards the same thing in monitoring our impact on oceans and ensuring that they're being cleaned up and that's successful. What role did Eve play in that? What sort of data did Eve collect to enable us to know what's happening in our oceans?
Well, I mean, the really exciting part of the project was that it was an understudied area. So out there in the Pacific, there wasn't a great deal of information. So sensors we had on board included temperature and pH, the ocean current service to the ATP. We'd able to tell us how the ocean was moving beneath the surface, and meteorological data as well. So there's a wealth of information that came through, sort of meta-ocean data, as well as the visual piece as well, which was kind of nice. But actually, the heart of it is in the science data. And
how is that being used now to inform science and indeed the wider community?
So that data has gone to the ocean cleanup, and their data scientists have been analysing it and producing papers. There's a pipeline of publications coming through now, actually. So yeah, so that will feed into what they want to do, but also be publicly available.
And from that deployment, what did you learn about Eve's performance? What worked? What didn't perhaps work as well as you wanted? What was going to be tweaked?
Oh, a huge amount. I mean, it's been a constant learning process for many years. I think Eve made us very happy because it was where we felt, okay, we've got this. This is a USV that really works. Getting out 50-day endurance was key. You know, our USP is being out there for weeks and ultimately many months. So the durability, which chimes with what Thibaut's saying as well. These systems are tested, you know, ferociously in the sea, and in the Pacific we had 4-metre swells, which we rolled through. It was fine. It's the constant battering in the northeast Atlantic and high latitudes that trouble us a bit. But we learned that the boat has endurance, and yeah, there's constantly tweaks and improvements to make. But thankfully, as the technology develops, it becomes diminishing returns. There are less, you know, there are fewer and fewer of these tweaks to make.
In this specific case, it was used as part of ocean cleanup. But what are the potential for Eve and for Autonaut in general in terms of the technology you've developed? What are the wider applications that it could be used for?
Well, there are many. That's been the wonderful part of being involved in Autonaut. There are so many ideas you can project onto the USV, and filtering them down to 2 or 3 that really work and have commercial viability is the challenge in many ways. The interest from defence, interest from the marine science sector, which has been a huge mainstay for us to, you know, put it full of sensors and use it to monitor the health of the ocean, the environment. And commercially, we're looking at things like, well, environmental monitoring typically, but also passive acoustic monitoring, so detecting marine mammals and assessing the soundscape around anthropogenic activities, such as oil and gas, and also as a communications hub, so using acoustic comms. I think Tom Rooney of Sonardyne was talking about this, you know, using the Autonaut as a hub to communicate to subsea assets or other assets such as the ecosubs and AUVs.
What was the reaction from the scientists and from other observers when Eve was doing its thing?
Scientists tend to really love Autonaut. You know, it's what Autonaut and you know, in common with most of these marine autonomous systems do is they put the scientists' sensors in the right place. They put them in hostile places where they find it very hard to get their data. So that, you know, you could be sort of a little bit dismissive and say, well, actually, they're platforms to put sensors in a position to get the data. The data is the valuable bit. So any marine scientist or commercial entity that's interested in the data, you know, has an interest in these systems and seeing them out there and finding the right role for them. and certainly in Autonaut in the Pacific, out in the wide blue, that was really where we like to be.
Let me bring Thibaut back in at this point, because there's a massive amount of work that's been done, but a huge amount still to be done. And we've talked about sort of on the water. What about on shore? There's a large entourage that follows you, the spectators, the infrastructure that's needed for every time you put a competition on. How is that going to change in terms of your ambition to go towards cleaner energy?
That's actually a really interesting question. It's not a question where we would have an answer right now. What we know is obviously we want SailGP to become more and more popular, so we can expect to have more and more people joining us either on the water or on the shore. So we know we have to work hand in hand with the city hosting our events on how we actually tackle these challenges. Well, I mean, you would have seen in my presentation that we are right now at a stage where we are monitoring our support to understand exactly what each boat doing on water. We are trying to work on projects where we could imagine maybe asking information to the support fleet as well, the spectator fleet, sorry, to then understand where they're coming from, how many people are on board, what sort of boat do they have, and what would be the impact on the water. We are also compensating the presence of the fans whenever they buy a ticket to actually come and join us at the event. And then it's an ongoing process. It's going to take quite some time. It's going to be ever challenging. So we just have to be very realistic about what we can do, what we can achieve, and find the right partners to help us on this aspect. It's also part of the requirements we have whenever we want to organize an event. With the discussion we have with the cities that want to have SailGP, they need to show strong commitment in supporting us in minimizing the impact around the racing.
And tell us what it's been like working with Plymouth as you prepare to have SailGP in the city of Plymouth. How has the city helped support you in terms of staging the event?
I mean, the city has been great from the very beginning. They've put a lot of efforts in having us here. We know how great the racing can be. We've seen it in the IC World Series a few years back. We're very much looking forward for the racing weekend. We know the conditions will be good. So we can feel, that the city is very much behind us. I would not be giving you like a lot of detail on what they've been supporting us because it's not in my role. We are like a large organization with a lot of different people working on it. I know we have some really strong project going on. If spectator would come to what you call the Hall by the lighthouse in Plymouth, you would see that we have a public village where we have a really long and large solar panel, which is powering part of the public area. And then we have some impact projects going on. As I'm speaking right now, we just had 2 boats leaving this morning from our tech site doing some seabed mapping in the protected seagrass area on the other side of the sound. So we are working on this together with the Ocean Conservation Trust. So we're working on a lot of different projects in every department. And for sure, Plymouth has been of great help and support on this.
We saw from your presentation a few minutes ago the desire to change the way that the support vessels are propelled. We will have a lot of marine tech businesses watching this because of the nature of the Expo. What would your message be to them? What precisely are you looking for in terms of cleaner support boats?
The first thing I would say is keep pushing because we know the technology is not there yet. So a lot of things need to happen. We are probably at the point where we see a switch in the industry, and you have companies who are, I would say, who are strong enough to take the risk in trying to initiate that switch. Some other companies are waiting, but I would say I'm really impressed by all the companies who are trying to bring new technologies to the market. It's a really interesting aspect, because we are in a relationship with community like associations such as World Sailing, but we also have the spectator fleet, and so we have people from I would say the top end side of the competition, and then we also have the leisure boating community. What we've seen so far is there is not one perfect technology. It's a combination of several technologies that could help us achieve our ambitions in being fully powered. It could be either hydrogen, electric, it could be even diesel running on HVO. So it all depends on what are your requirements on the water. Some boats have really strong requirements in terms of speed or range or power we need for safety. Some can actually achieve lower speed, so you could have a different technology. Some need to carry a lot of weight. Some are spending like hours on the water. Some are just there for a couple of hours for the racing. So what we're doing, and as you could have seen in our presentation, we're trying to understand exactly how we operate each and every boat that we have in our fleet. So we are monitoring them in real time, collecting the data. And then by having this data, we will be able to draw a profile for each role and then have a discussion with some technology suppliers who could then help us find the right technology. But yes, no, I would say just keep pushing because we know it's the right way. It's just a matter of time. And if I can add something, it's beside the technology, it's how you conceive a boat. You know, we know that foiling is something which is going big. And I think the technology you adapt for the engine very much depend if you could have your boat foiling as well. And this would just completely change the way you operate and the way you set up your racing, or like how racing and how training.
One of the things you're talking about is minimising race days as well, to minimise the sort of overall impact of SailGP. I just wonder how you monitor the balance, that you don't strip away so much that you take away the enjoyment for spectators and competitors. How are you trying to make sure you strike the right balance here between going to cleaner energy and also not stripping away too much of what makes SailGP so exciting?
I think it's a conception. Probably a lot of people think that you can't integrate sustainability into performance. So sometimes being sustainable means you can't be performing, whereas we want to show that you can redefine what performance is. The good thing about our racing is we have one design boats. So whatever we do on our boats, in our team, it's the same for everyone. If we were to implement a rule on the number of boats you can have on the water, or the number of hours you could be training, this would be the same for each and every team. So this, as long as the game remains fair, we think it's good enough. Then for the spectator, I don't think it's about quantity, but it's about quality. We could have seen it during the Euro, you know, like 90 minutes of a football match is enough to have a lot of emotion. So you could organize racing over just like we do, a weekend on Saturday and Sunday, and still have great racing. You would not be compromising on anything. So now for us, the journey is very much about redefining performance. How do we at SailGP, and how do the teams, the skippers, the sailors, the shore team members, how do we integrate this impact dimension into their performance, the daily performance?
Phil, back to you briefly, and I wanted to look at the crossover between sectors, which we've talked about a lot during this Expo. It strikes me that so many of the technologies being developed independently by companies all sort of link together in many ways. How closely is Autonaut working with other parts of the sector here in Plymouth and the wider Southwest?
A lot, and it's increasing as well. And a big part of that is the momentum that Plymouth has with the Expo and the Ocean's Gate, the Smart Sound. There's been a lot of companies working here kind of independently in the Sound for many years, but wrapping a bow around that in the last few years and actually realising that we're shoulder to shoulder, we've got a lot to offer each other has been fantastic. But also looking outward, you know, so we have a lot of links to the Solent and of course in the wider UK, and looking further afield. So that element of collaboration with the marine autonomy has been really vital the last few years. But now I think we're also beginning to look around and look to people like SailGP to find out what materials work, what systems work. There's a sense of maturity where marine autonomy is coming to, so it's a good place to really deepen those collaborations.
And within the world economy, where does the UK fit when it comes to developing these sorts of technologies? Are we sort of, is the UK a leading presence now in this?
Yeah, I think so. I think it's fair to say the marine technology and from our field of marine autonomy, it's definitely got its nose ahead. But of course, we've been here before. We've had the UK has a habit of being pioneers but letting it slip. Actually, there is a place, and it's great to be part of a smaller cluster. But as I say, looking beyond. So Canada, there's some great stuff going on in Canada. Obviously, US always, and Australia and elsewhere in the world. So whilst I kind of feel confident UK has got a real head start, it has to. The momentum is keen to keep going, and that comes from looking outward as well.
Some of the world-leading research we've seen during this Expo includes the biofouling that we saw in the previous presentation from Yunnie, and looking at how to minimise the impact of biofouling. How much of an effect did it have on Autonaut, on Eve, and on your vessels? How much of an issue is biofouling?
It's been a constant source of worry over the years, and actually I think now we've got having got the endurance under our belt from the USV, because obviously that's when the biofouling kicks in. It feels okay. Yeah, we're on top of this, and very keen to see Annie's work and other techniques as well. So we've been through various techniques. And we've had some, few instances of strange creatures off West Africa. We had a job in the tropics where we had these unusual beasts kind of emerge on the platform. But actually in the Atlantic here, the growth is pretty vociferous. So yeah, it's a constant thing. But what we worried about previously has been effects in terms of hampering the performance of the boat, the mechanical propulsion. The floors are quite delicately balanced, but actually it's often the sensors. So it's the clogging up of the sensors that reduce our mission time. But there are ways and means, and it's able to extend the endurance all the time.
And Thibaut, let me bring you in on that point as well. I don't know how much of an issue it is for your boats and how long they're in the water. I mean, is the cleaning and the clearing off of biofouling much of an issue for your boats? And if so, how are you dealing with it in part of your wider ambitions for cleaning up the environment?
No, actually, it's not an issue for us, because we for the A50 we craning them in the morning in the water, and then we crane them out in the evening. So we don't have this issue. And for our support fleet boats, they are only staying in the water for 4 or 5 days. So we don't do anything particular around that aspect, which is good, I would say.
We've been talking about autonomy a lot during this Expo, and it was interesting to see in your presentation the move towards remote umpiring. Tell us a bit more about how that's going to work.
So the remote umpiring, it comes from different conclusions. The first one is considering how fast the F50 are now. It's really difficult for the umpires to follow. It makes their life on board a powerboat to follow the F50 pretty difficult. Then you have also a risk of collision in a very dense racing with 8 boats sailing around. And then through technology now, we are actually more accurate to umpire from a distance, because as you would have seen on my presentation, we have a really detailed software where we have the position on the boat, and then we see exactly where they are on the race course, how far they are from the boundaries, if they're on starboard or on port, so we know which one has a priority over the other one. And then we have some distance around this F50, so we know when there is one boat breaking the rule. So this has played a massive difference in keeping the umpire from far away. They can just stay at home and umpire from a distance, so they might also be in better conditions to judge properly. And then it's been really very much streamlined. It's been a great process. We also have a semi-remote race management system where Ian Murray, our race director, is actually working from home as well. So he's in Australia. And then we have someone here, Melanie Roberts, who is on a boat, and then they're just liaising from distance, either using Skype or Google Meet or some other tools. And then they've been able to work remotely on this. So this is a very big thing for us. And looking forward with the events we will have in Sydney and in Australia at the end of the year, and in New Zealand early 2022. And as per the current COVID restrictions, we're trying to find ways so we are able to operate more remotely and find local resources to help us. So I'd say it's part of the thing as well. If you don't need to travel people all around the world, then obviously you're minimizing your impact, and you also give a chance to create communities of people working with you all around the globe. So it's a really good opportunity for us.
Having said that, there are obviously still going to be a lot of people who will have to travel all over the world as part of this event, and that, of course, in itself contributes to carbon emissions. How are you minimizing your travel impact on the environment as you travel around the world?
To give you a really quick conclusion, just by reorganizing the way we operate. So we have 8 teams. Each team has a short team, and then we have what we call shared services, which is a group of people shared in between the teams for every department, such as electronics, hydraulics, foil, boat building, rigging. And this has made our life so much easier, because instead of having to source specific staff for each team, then you are able to rely on a bigger group of people, which are very much skilled. But at the end of the day, you will actually reduce the number of people you're flying to an event. As an example, we had, I think back in 2019, around 350 people traveling to each and every event. And now we are between 150 to 200 person, considering we've had one extra team. So as an example, I'm working for the French team also, and we were about 20 people traveling in 2019, and we are only 14 people traveling now, so it's 6 people less, and then we are 8 teams. So, you know, this has happened in every department. Through technology, we're able to do things from far away. We also have been able to work on a production system where we just send people to the event that need to capture the content, you know, a photographer, videographer, and so on. And then the feed is actually sent back to a studio in London that then spread the feed to all the different TVs. So we don't need to fly people everywhere around the globe as well. And this is great, you know, because technology has been helping us a lot on this. And this is something we could imagine then duplicating for other events in the world of sailing, or maybe other sports events generally.
Finally, the competition itself obviously very much depends on weather and sea conditions. How are things looking ahead of the Plymouth section?
It's looking pretty light, but normally sun should be shining. It's pretty light, but we're not so much scared about the wind condition. The great thing about these boats is we have, as you can see just behind me here, we have a wing, which is pretty much like a wing of an airplane, and then we can adjust the length of this wing. We have 29 meter, which is a light air wing, which we won't have in Plymouth, but we will have on the other events onwards. And then we have a smaller wing as well. And we can also adjust the number of crew on the boat. So they normally sail at 5 people on board, and we've seen in Toronto in the last event we had in Italy last month that we had only 3 people on board, and then we were still able to have the boat folding in as low as 5 or 6 knots. So we should be fine. It's going to be a lot of fun, a lot of good racing, and we're very much looking forward to Saturday and Sunday.
Something to look forward to for spectators. And before we go, Phil, looking ahead, what's next for Autonaut? What are the sort of things you're working on at the moment?
Oh, we always got projects in the pipeline. The big one for us is the launch of the PML Pioneer, which will happen very soon, and that will, you know, as I say, will be it'll be an example of cutting edge technology and the smart sound. So we're also delivering to across Europe as well, boats, and we also have a project this summer in the Northeast Atlantic. So heading out from Scotland on an ambitious mission towards Osnap, the Mid-Atlantic, and returning. So
and Eve being deployed again, I think.
Eve is going to be deployed again. I think later this year. That may change, but that's the latest I have.
Okay, good to look forward to that as well. Thibaut, good luck with everything going on at Plymouth for SailGP and the ambitions to become clean energy. Thank you very much indeed for taking part in Marine Tech Expo 2021. Phil, thank you for your contribution as well. And thank you to everyone who's taken part so far in Marine Tech Expo 2021. Another break coming up now, but when we come back, we'll look more at the developments in wind energy and offshore tidal energy and the power of the sea. Plus, we'll look ahead to more of the monitoring that goes on in our oceans and some of the technology being developed in the UK to help monitor what's happening in the world's oceans. So join us for more after this break.